In your pocket, on your desk, or inside the device you're watching this on sits the greatest paradox of the modern world. We sent robots to Mars, split the atom, and built artificial intelligence. And yet, every night we crawl back to a wall outlet. The first thing we check in the morning isn't the news, it's that tiny battery percentage. When it drops below 20%, something shifts inside us. A quiet panic. Our lives depend on the mood of lithium ions. But here's the real question. Why doesn't battery technology double every year like our processors do? Why are batteries still heavy, risky, and frustratingly limited? To understand that, we have to look at a dead frog, an ancient clay jar, and even your own body. Let's start at the beginning, the moment humanity tried to trap electricity inside a box. Before batteries, electricity was just a spectacle, a spark, a shock, then nothing. In 1745, scientists believed electricity was a fluid, something like water, and if it flowed like water, surely it could be poured into a container. That idea created the Leyden jar, the first capacitor. It could store electricity, but there was a problem. It released everything at once. It wasn't a dam, it was a bucket. Tip it over and it's empty. What we needed wasn't a bucket, we needed a faucet. While scientists experimented with glass jars, nature had already solved the problem millions of years earlier. In the rivers of South America lives the electric eel, a living battery. Inside its body are thousands of stacked cells wired in series. When it strikes, it can release over 800 volts. Alessandro Volta studied this phenomenon closely. When he built the first true battery, he wasn't inventing something entirely new. He was copying nature. The first battery was biomimicry. And the story goes deeper. As you watch this, billions of tiny batteries are working inside you. ATP molecules inside your cells constantly store and release energy. Your mitochondria charge them. Your body spends them. You are not just biological, you are electrical. And that realization sparked one of the greatest scientific rivalries in history. In 1780, Luigi Galvani touched a dead frog's nerve with a metal scalpel. The leg kicked. He believed he had discovered animal electricity, a hidden life force inside living tissue. Alessandro Volta disagreed. It's not the frog, he argued, it's the metals. To prove it, he removed the frog completely. He stacked zinc and copper discs, separated by salt-soaked cardboard, and he created the first battery, the voltaic pile. The frog was dead, but the modern world was born. Yet even that might not have been the beginning. In 1936, archaeologists near Baghdad uncovered clay jars more than 2,000 years old. Inside were a copper cylinder and an iron rod. When filled with acidic liquid, they produced electricity. No one knows what they were used for. Electroplating, rituals, experimentation. We still debate it, but the principle hasn't changed in 2 millennia. A battery is simply controlled electron movement. Strip away the formulas and a battery is simple. An anode, a cathode, and an electrolyte. One side crowded with electrons, the other side waiting. Electrons want to move. The electrolyte blocks the direct path, so we force them through a wire. That flow is what powers your phone right now. Anywhere electrons move between two metals through an electrolyte, you have a battery. A lemon, a potato, a glass of salt water. Even you, your body is filled with electrolytes. You are walking chemistry. So, why do batteries die in winter? They don't. The chemistry just slows down. Cold thickens the electrolyte. Ions struggle to move, like walking through honey. The energy is still there, it just can't escape fast enough. Warm it up and it comes back to life. For decades we were told don't charge before it's empty. That was true once. Old nickel batteries suffered from the memory effect. Lithium batteries don't. In fact, they prefer frequent partial charging. They age from stress, not from use. Lithium changed everything. It's the lightest solid element on Earth and one of the most eager to give away electrons. Perfect for batteries, but dangerously reactive. Touch water, it ignites. Expose it to air, it can explode. In the 1970s, during the oil crisis, scientists dreamed of electric cars. But lithium kept catching fire, until John Goodenough found a way to tame it. Instead of using pure lithium metal, he trapped lithium ions inside layered metal oxides. Stable, rechargeable, powerful, the lithium-ion battery was born. He received the Nobel Prize at 97, and the device in your hand exists because of that breakthrough. Today, lithium batteries don't just power phones, they power heart. Millions of people carry pacemakers powered by lithium, a tiny battery beating silently inside a chest for over a decade. Energy sustaining life. But there's a shadow. Lithium-ion batteries require cobalt. More than 70% of the world's cobalt comes from Congo. Many mines operate under harsh and unethical conditions, and lithium extraction consumes vast groundwater in South America's lithium triangle. Oil wars may be fading, lithium wars may be beginning. So what's the way forward? Urban mining. Recycling old electronics yields more usable lithium and cobalt than mining fresh ore. The richest mines on Earth may be in your drawer. And while we debate batteries here, some have already left the solar system. NASA's Voyager spacecraft run on nuclear batteries called radioisotope thermoelectric generators. They convert radioactive decay into electricity. No recharging, no sunlight required. They run on time itself, humanity's quiet heartbeat in deep space. Are we trapped by lithium? Maybe not. Hydrogen fuel cells offer another path. If lithium batteries store energy, hydrogen cells create it on demand. Hydrogen meets oxygen, the result is electricity and water, nothing else. A vehicle that emits only water vapor would have sounded like magic in Galvanistan. Today, it's engineering. We stand at a crossroads, safer solid-state batteries or hydrogen's clean promise. This isn't just about technology, it's about what kind of civilization we want to power. A battery is not just a metal box, it is the greatest energy revolution since fire. We didn't just learn how to generate energy. We learned how to carry it. From a twitching frog's leg to Voyager's nuclear heart, this is the story of controlled electricity. The next time you plug in your phone, remember, flowing through that cable is more than current. It is 200 years of rivalry, risk, discovery, and courage. Where there is energy, there is life.